Hello students, I am Sharvari Sane from Electrical Department. In today's video, we are going to see how the power is measured in the three-phase. Now while measuring the power into the three-phase supply, first of all we require one device which is known as a wattmeter. So first we will see what is the construction of the wattmeter. Wattmeter consists of two coils. Number 1, it is a current coil, and number 2, it is a voltage coil. So, the symbolic representation of the current coil is a inductor type or coil type, so it is a current coil. And this is nothing but the pressure coil, which is quite similar to the resistance. Now, current coil is connected in series with the load. So this will be the load, and supply is given through this part. So this is nothing but the AC supply. Now current coil and pressure coil. Now in this case, apart from these two coils, there are 4 indications are normally used. And these indications are M, L, C and V. Now M, as it is connected to the main supply, so it is a M. L is connected to the load, so it is known as a load. Then it is a common point between the current coil and the pressure coil. So that's why it is known as a C. And this is the voltage point, so it is known as a V. It is necessary to understand that what is the role of these two coils. Now if you checked it clearly, you will find that current coil is connected in series and the pressure coil is connected in parallel. It means that indirectly current coil is playing the role as an ammeter and the potential coil is playing the role as a voltmeter. Now the reading of this entire arrangement is given by P, which is equal to V into I cos theta. So it is going to measure the voltage and current and with the angle associated with that. So indirectly it is measuring the active power by using this meter. Now by using this one meter, which is known as a wattmeter, we can measure the power into the three-phase supply in 3 different ways. Number 1, it is a 1 wattmeter method. Number 2, it is a 2 wattmeter method. And number 3 is definitely 3 wattmeter method. Now as the name is suggested, 1 wattmeter method, 2 wattmeter method and 3 wattmeter method. It is clearly indicate that we are using only one wattmeter to measure the three-phase supply. Here we are measuring 2 wattmeters and here we are measuring 3 wattmeter. But it's to be noted that always that the 2 wattmeter method is normally used and practically good for measurement of the three-phase power. Now first of all, we will just concentrate how to measure the power in 1 wattmeter method. So in that case, for 1 wattmeter method, the connection is shown that I am measuring the power in star connection for the load and only 1 wattmeter is used over here. Now in this case, just see the connection. Here I am using the 3-phase R, Y and B. But apart from that, there is a 1 star point and which is known as a neutral is connected here. So this is known as a neutral point. Now when connection or doing the connection of that wattmeter, the current coil is connected to one of the phase and potential coil is connected across any phase and the neutral. So this will be nothing but my wattmeter reading. In this case, this wattmeter is going to measure the power across R and N, or it between Y and N, or between B and N. But as I am using only one wattmeter, so the power which is measured by this is given by P is equal to, which is per phase, so it is equal to V per phase, I per phase, and the angle between that voltage and the current. But while doing the calculation part, as only one wattmeter is used for one phase, so as I am measuring for the power for the 3 phase, so the same reading is multiplied by 3. So VPH, IPH cos theta. Now the advantage of this particular method is that we are using only one wattmeter, but at the same time it is very difficult to trace this neutral. Now this difficulty can be overcome by using the 2 wattmeter method. Now 2 wattmeter method we will explain in brief. So now second one will be the 2 wattmeter method. In this case, whatever be the difficulty of the neutral tracing can be avoided in that case. It means that I am going to use 2 wattmeter method. Current coil will be connected 2 phases and the pressure coil will be connected to one of the remaining phase. So I am just drawing the diagram for the same. These diagrams are different for the different books. So accordingly, the connection as well as the phasor diagram has been drawn. So as I told you, this is one of the very important method for understanding the power measurement. In this diagram, I am showing how the power is measured in the star form for the 2 wattmeter method. So this will be my wattmeter method, 2 wattmeter method, R phase, Y phase and B phase. Now while doing the connection, I will just take care that my current coil of first wattmeter method is connected in this way for the R phase, and the pressure coil is connected between R and Y. This will be nothing but my W1. Now second wattmeter I am connecting to the phase B. So the connection will be like this way, and this I will call it as a W2. So this will be for the W1, this will be the current coil and this will be the pressure coil. For the W2, this will be my current coil and this will be my pressure coil. Now if you observe this diagram clearly, I am not using the neutral in this case. This diagram is different as per the different authors. So some are connected between R and Y directly, and for the remaining phase, here I have connected between R and B. So I am going to use the phasor diagram similarly or following the same diagram. So this is indicating my all loads which are same because I am using the balanced circuit. Now the current flowing through this phase is IR, this will be IY and this will be my IB. Now the voltage which are measured across these two lines will be the VRY, VYB and VBR because I have taken the sequence RYB. I am using the star connection, so I have to follow the rule of the star connections. So in that case, if I am considering the phase value over here, so if I am connecting the voltmeter across the terminal R and this neutral point, it is going to measure my VR. Then if I am connecting the voltmeter between the Y and the neutral, that voltmeter is going to measure the Vy. So like that way I will get all the phase voltages, and so phase voltage Vph is equal to Vr, Vy and Vb. Now at the same time, if I am connecting the voltmeter across these two terminals, so it will be VL, which is equal to VRY, VYB and VBR. As it is a star connection, again the current will be same for line as well as for phase. So IL is equal to IPH is equal to IR, IY and IB. So by using this connection, we'll develop the further phasor diagram. By using this particular diagram, now we can develop the reading of W1 and W2 separately. W1 will be equal to now just see W1, the current coil is connected to the R phase. So it is going to measure IR, and this pressure coil is connected between R and Y. So it is going to measure the voltage between R and Y. So I can write the current, which is IR, voltage is VRY and the angle between IR and VRY. So cos of IR and VRY. Similarly, for W2, you can check that the current coil is connected to the phase B and pressure coil is connected between the B and Y. So it is going to measure the current IB and the voltage between B and Y. So it will be IB and voltage is VBY and the angle is IB and VBY. Now after getting this equation, it has become essential to find out the exact angle between the IR VRY and IB VBY. Now for that reason, it is necessary to draw the complete phasor for the given diagram. So as it is a star connection, I will take the reference as a voltage. So this will be my VR, this will be my VY and this will be my VB. Now these three are 120, 120 and 120 degree apart from each other. I am considering the lagging power factor. For that, my current will be lagging to the each voltage by the power factor angle theta. So this will be my IR, making the power factor angle theta. This will be my IY, making power factor angle theta, and this will be my IB, making the same power factor theta. As it is a lagging power factor, as I mentioned, the currents are lagging to each phase by angle theta. Now coming back to the equation again, I want to find out the current angle between IR and VRY. So for that, I need VRY. Right now I have only phase voltages. So for that purpose, I need the resultant of VR and VY. Now for that purpose, I need the reflected component of Vy. So I will be getting the reflected component of Vy here, which is making 180 degree with the Vy, and drawing the complete parallelogram for this, I will be getting the resultant, which is VRY. Now why I taken VRY not VYR? Because my R was a real component and Y was a reflected component. Now I got the resultant VRY. Similarly, in the second case W2, I want to find out the angle between IB and VBY. Now I have a VB and I have the reflected component of VY. So I will draw again the parallelogram for the same. And this will be my VBY. Again here my VB was a real component and VY was a reflected component, and that's why I have taken the VBY. After getting these two values or the two resultant of the voltages, now I can easily find out the exact angle between the current and the voltages. Now as it is already mentioned that IR and IB are the phase values or the line values, at the same time VRY and VBY are my voltage line voltages, and the angle is already calculated or shown over here. Now I will try to mention in terms of the exact angle. So I am rewriting the equation that W1 is equal to IL, VRY is a VL. Now if you just check the diagram first, current is IR over here and this will be my VRY. So the exact angle between the IR and VRY will be theta plus 30, because as it is a parallelogram the total will be 60 and half of that will be the 30 angle. So it will be VL IL cos 30 plus theta. I will call it as the equation number 1. Now coming back to my diagram again, I want to find out the value of W2. Now W2 is IB, VBY and the cosine angle between IB and VBY. So for that, again I am going back to my diagram. I have VB over here and I have VBY over here. So what will be the exact angle between these two? Now the total angle is 30, but in that again theta is there. So what will be the remaining one? So definitely it will be 30 minus theta. So I can write the equation that IL VL cos 30 minus theta. I will call it as the equation number 2. Now I have two equations with me. If I take the summation of this 1 and 2, I will be getting W1 plus W2, which is equal to, I am taking the common part in these two equations, which is nothing but IL and VL. So IL, VL with the angle cos 30 plus theta plus cos 30 minus theta. By using the trigonometry equation for cos 30 plus theta and cos 30 minus theta and adding these two values, we'll be getting the equation that VL, IL as it is, and if you open the bracket, this value will be coming to cos 30 and cos theta. Now if you open this part, taking the value of cos theta, it will be a root 3 VL IL cos theta. So I got W1 plus W2, which is equal to root 3 VLIL cos theta. I will mark this as the equation number 3. Similarly, if I will take the subtraction between the 2 and 1, so I will be getting the equation that W2 minus W1, which is equal to, again from this equation I am subtracting equation number 1 from 2. So Common part is VL, so VL, IL is as common. Then by taking the equation cos 30 minus theta minus cos 30 plus theta. Again here also, by using the trigonometric equations of cos 30 minus theta and cos 30 plus theta after opening the bracket, I will be getting the equation is that VL IL sine theta. This will be nothing but my equation number 4. So I will be having two equations with me, that W1 plus W2, and here it is W2 minus W1. So I already mark here 3 and here it is a 4. If I will take the ratio of equation number 4 to equation number 3, on the left hand side it will be W2 minus W1 upon W2 plus W1, which is equal to VL IL sine theta upon root 3 VL IL cos theta, which is on the right hand side. Now sine theta upon cos theta is tan theta, and this VL can be cancelled. So finally I will be getting the equation W2 minus W1 upon W2 plus W1, which is equal to tan theta upon root 3. Now if I take the tan theta with me on the cross multiplication part, so tan theta is equal to root 3 W2 minus W1 upon W2 plus W1. And finally, we can write the equations that theta is equal to tan inverse root 3 W2 minus W1 upon W2 plus W1. Now this is nothing but my final equation, where I am directly getting the value of theta and along with the equation of the wattmeter readings. For lagging power factor now, the equation will be theta, which is equal to tan inverse root 3 W2 minus W1 upon W2 plus W1. So this is for the lagging power factor. Now how to calculate the theta for the leading power factor? Now the only thing that we are supposed to do, just multiply by the minus sign. So if you are multiplying by the minus sign to the numerator part, that W2 it is becoming negative and W1 is becoming positive. That is the only change for the leading power factor. So I am writing it again, the same equation for the leading power factor, that the equation theta is equal to tan inverse root 3. Now it will be W1 minus W2 upon W2 plus W1 as it is. So this will be for the leading power factor. At the end, that if the reading of the two wattmeters are given to us, we can calculate the theta, which is nothing but the power factor angle. So theta is equal to tan inverse in the bracket root 3, and always remember that it should be the high value minus low value upon high value plus low value. That's all. So high value minus low value upon high value plus low value. This will be for the standard any value. So this is the standard equation for any case where we have to calculate the theta from that. Now by using these three equations or any of that as per the question, from this equation we can find the theta, from that cos theta, and we can find W1, W2 separately also if it is given, and as per the leading power factor only we have to multiply the numerator by minus sign, so changes will be W1 minus W2, and the standard value or the standard equations for calculation of theta is tan inverse root 3 high value minus low value upon high plus low. Thank you very much. Always remember that the wattmeter is not showing any negative reading. Now, in some problem, the value of W1 and W2 are given directly. But in some cases, they are just telling you that the one of the wattmeter connection has been reversed. So in that case, for the lagging power factor, here W2 will be as it is, and it will be W1 will be negative. So it will become W2 plus W1. And denominator will be changed, that W2 minus W1. That only we have to make the changes. Now for the different load which we are connecting to the three-phase supply, as per that the power factors are going to be changed or the wattmeter readings are going to be changed. So we'll just see what will be the effect of the power factor on the wattmeter reading. So it will be effect of power factor on wattmeter reading. Now while understanding this part, because this is normally asked in the theory part, so it should be known to us that what will be the exact effect. What is the meaning of this? There is a possibility that the load may be purely resistive, it may be purely inductive, it may be the purely capacitive, or maybe the combinations of RLC. So in that case, what will be the reading of my W1 and W2? So standard equation of W1 that is already derived in the previous part, that VL IL cos 30 plus theta, and W2 is equal to VL IL cos 30 minus theta. Now here we are considering these are my two standard equations. Now based on these two equations, I can find out the effect of the power factor on the different load. In case 1, I am considering my power factor is equal to 1. And definitely in that case, my theta is equal to 0. Now what do you mean by the power factor is equal to 1? It means that voltage and the current, they are in phase. And when the voltage and the current are in phase, when the load is purely resistive. So in that case, if I substitute 0 in these two equations, we'll just check out what will be the reading. I'm just replacing this 0 in my standard equations of W1 and W2. So my W1 will be now VL IL cos 30 and W2 will be VL IL cos 30. What is the meaning of these two equations? These two equations indicating that when the power factor is 1 or the theta is equal to 0, the readings are both are positive and both the wattmeters are showing the reading. and this is same reading. So if the question is asked in which condition or what will be the power factor when both the wattmeters are showing same reading, so our answer should be the theta is equal to 0 and the power factor is equal to 1. It means that it is a resistive circuit or it is a purely resistive circuit. Let us think about the second condition. When theta, or first of all, power factor is equal to 0.5. When power factor is equal to 0.5, theta is equal to 60. Now in that case, I will be again substituting 60 value in this equation instead of theta. So my W1 will be VL IL cos 30 plus 60. So I am directly write down it will be 90 degree. And W2 will be VL IL cos 30 minus 60. So it will be minus 30. Now cos of minus 30, it is becoming 30 only. So I can write the value of this equation, that as cos 90 is 0. So VLI into 0, the reading will be completely 0. And this will be my VL IL cos 30. It means that when power factor is 0.5 or theta is equal to 60 degree, in that case only one wattmeter is showing the reading, but the another wattmeter is not showing the reading or it is showing 0. So question can be asked, what is the power factor when only one wattmeter is showing the reading? So answer is the angle is 60 and the power factor is 0.5. Now condition number 3. There is a possibility that the power factor may be less than 0.5 but greater than 0. It means that it is lying between 90 degree and 60 degree. Now in that case, if you substitute the value, the W1 will be negative and W2 will be positive. That is the conclusion. So this is the condition when the power factor is in between 60 and 90. Now let us go for the last one, which is the fourth condition. And this indicates that power factor is equal to 0. It means that theta is equal to 90 degree because cos 0 or cos 90 is equal to 0. In that case, I am substituting theta is equal to 90 in my standard equation. So it will be W1 which is equal to VL IL cos 30 plus 90. So it is becoming 120. And this value is becoming minus VL IL sin 30. Similarly, I will substitute the value of 90 in my second equation. So W2 will be VL IL cos 30 minus 90. So 30 minus 90, it will be minus 60, and minus 60 will be nothing but 60 only. So this value is becoming VL IL sin 30. Now just check these two values. Their magnitudes are same, VL IL sin 30, VL IL sin 30. But at the same time, it is having negative and this is the positive. So if I'll take total power for this is equal to 0 because one value is negative and another value is positive. This is possible only when the power is equal to 0, when the angle is 90. And when the angle is 90, angle between the voltage and the current is 90 when when there is either pure inductor or pure capacitor. This is the condition when the power factor is equal to 0. So ultimately, if the question is asked if the two wattmeters are showing the same value with the different sign, then what will be the power factor? So in that case, the angle is 90 and power factor is 0. So these are the 4 conditions that we have to remember. Now, apart from that, always remember only 3 equations. Number 1, when the power factor is lagging, it is tan inverse root 3 W2 minus W1 upon W2 plus W1. When it is leading, you have to just change the value of sign in this case. So I am just multiply minus sign. So now the numerator part is going to be changed. And the standard equation is high value minus low value upon high value plus low value. So these are the 3 equations that we always remember for that. And one condition is as what if the connection of one of the wattmeter has been changed. That one of the wattmeter is normally the second one. So here W2 will remain as it is, but the sign of that W1 is going to be changed. So this will become positive and this will become negative. That is the only change we have to consider. Remaining thing will be remain as it is. Thank you very much.